humankind, because of the James Webb Space Telescope, might have to reconsider an enthralling disclosure. The telescope has uncovered an enthralling spine-chiller in Proxima Centauri, the nearest enormous star system to us. In the midst of its Proxima Centauri, the nearest star system stands separated with odd phony lighting, leaving the presence of mind area interested. Should this be the expansive anticipated attestation of outsider life past our planetary framework? How do investigators decide whether those lights propose the presence of wise life on Proxima b? As we dive into how the James Webb Space Telescope has seen what may be city lights 7 trillion miles from Earth, obviously, interest in the universe's exceptional pieces of information stays colossal. Mechanical advances have pushed our capacity to investigate Earth and the sky, provoking us to explore the immense fields of the universe. Earth stays the main planet known to hold life, and the deep-rooted question endures. Are we uncovering the presence of extraterrestrial life, or are their flags simply aspects of the grandiose foundation? In 1984, two American space experts, Jill Tarter and Thomas Pearson, started an undertaking called the Search for Extraterrestrial Intelligence. This charitable endeavor plans to channel through profound space radio transmissions, as these signs travel monstrous distances and are the essential technique for looking for extraterrestrial correspondence. The 42 radio telescopes set in the Californian flood mountains were carefully tuned to the universe's frequencies. These telescopes, known as the Allen Telescope Array, were intended to recognize any atypical signs from space. Regardless of broad perception, no persuading proof of signs from an extraterrestrial human advancement has been distinguished. Late updates from NASA recommend that the James Webb Space Telescope, JWST, might have additionally seen fake city lights from neighboring planets. This brings up the issue of whether the JWST could without a doubt be humankind's monster jump forward in investigating the universe. The JWST is the most advanced instrument in humankind's set of experiences for understanding the universe, situated around 1 million miles from Earth. This enormous telescope fills in as our window to the earliest sagas of the universe, giving more clear bits of knowledge into the arrangement of structures, stars, and planets. Prepared with cutting-edge cameras and channels, the JWST empowers space experts to investigate the huge range of inestimable peculiarities by dissecting explicit light frequencies. The JWST explores exoplanets for signs of life, and its unmatched capacity to peer past traditional cutoff points has led to breathtaking disclosures. For example, the JWST has identified more systems than previously known, uncovering a more profound comprehension of the universe's association and improvement. As humankind pushes to explore the farthest reaches of space, the JWST plays an essential role in uncovering the secrets of far-off universes. The disclosure of over 4,000 exoplanets circling far-off stars exhibits the astounding advancement in our journey to grasp the universe. Red dwarf stars, being more modest and cooler than our Sun, present prime opportunities for reading up possible livability. For model, the TRAPPIST-1 framework, with its 7 Earth-sized planets, incorporates 3 inside the star's livable zone, where conditions could uphold fluid water. In spite of its cooler temperatures, TRAPPIST-1 discharges a delicate, Earth-like light, recommending that its planets could hold life. Comparatively, Proxima Centauri, the nearest huge star to our planetary group, is a feebly shining star, and any planet circling it would be nearer than Earth to the Sun. However, its planets may not keep up with conditions helpful for life. The investigation of exoplanets has opened a tremendous span of potential, uncovering various planetary frameworks past our own. Red dwarf stars, being the most well-known type in the universe, offer energizing possibilities for tracking down livable planets. Notwithstanding their cooler temperatures, the TRAPPIST-1 framework, with its closeness and water vapor presence, highlights the potential for life-supporting conditions. The JWST, with its advanced instruments, keeps on upsetting our understanding by examining exoplanet environments and identifying key particles indicative of organic action. As researchers examine outrageous conditions on Earth, like those occupied by extremophiles, they gain insights into the potential for life in brutal circumstances somewhere else in the universe. The investigation of outrageous conditions extends our comprehension of life's flexibility and expands the search for extraterrestrial life, whether microbial life on a far-off world or advanced civilizations. Every disclosure carries us nearer to responding to one of humankind's most significant inquiries. Are we alone in the universe? As mechanical progressions like the JWST impel our capacity to investigate further into the universe, the journey for life beyond Earth continues to be one of the most enthralling undertakings in science. The JWST, outfitted with best-in-class instruments, vows to reveal the universe's mysteries and shed light on the potential for life beyond our solar system. The search for extraterrestrial life is one of humankind's most significant and captivating attempts. As mechanical headways push the limits of what is conceivable, the James Webb Space Telescope, JWST, stands at the very front of this investigation. Its modern instruments and exceptional abilities permit researchers to explore far-off exoplanets and their climates in manners previously unreachable. The JWST's capacity to identify and investigate barometric creations provides critical insights into the potential for life-supporting conditions on exoplanets. By looking at the presence of key atoms, for example, water vapor, carbon dioxide, and oxygen, researchers can derive the probability of tenable conditions. This is particularly critical in the quest for planets that might have conditions comparable to Earth's, where life, as far as we might be concerned, might actually flourish. Notwithstanding its investigation of Earth-like planets, the JWST additionally centers around more limit conditions, including those around red dwarf stars. These stars, while cooler and dimmer than our Sun, are the most widely recognized type in the universe and often have planets within their habitable zones. The TRAPPIST-1 framework, with its 7 Earth-sized planets, is a perfect representation of an objective for such examinations. Notwithstanding the cooler temperatures of TRAPPIST-1, its planet's closeness to the star and the presence of water vapor propose that these worlds could uphold life. The investigation of extremophiles on Earth, creatures that flourish in outrageous conditions, provides valuable bits of knowledge into the kinds of conditions where life could exist somewhere else. Extremophiles, which can survive in outrageous temperatures, acidic conditions, or high radiation levels, challenge our comprehension of life's cutoff points and expand the scope of potential habitats beyond Earth. As our innovation advances, how we might interpret the universe expands. The search for extraterrestrial life continues to evolve. The JWST, with its cutting-edge technology and capacity to look into the far-off universe, represents a significant jump forward in our exploration endeavors. Each new disclosure, whether it be a far-off exoplanet or a novel extremophile, adds to the growing mosaic of how we might interpret the universe and our place within it. The investigation of exoplanets and outrageous conditions not only seeks to answer the basic inquiry of whether we are distant from everyone else, but also enhances our knowledge of the circumstances essential for life. The insights acquired from the JWST and other advanced technologies will shape how we might interpret the universe and guide future missions in the search for life beyond Earth. In conclusion, the quest for extraterrestrial life is a dynamic and developing field driven by advances in technology and our ceaseless interest in the universe. The James Webb Space Telescope, with its remarkable capacities, assumes a crucial role in this attempt, offering new points of view and possibilities. As we proceed to explore the vast expanse of space, each disclosure carries us closer to unwinding the secrets of the universe and figuring out our position in the grand cosmic plan. As we plan ahead, the James Webb Space Telescope, JWST, is supposed to be an essential device in the ongoing journey to find extraterrestrial life and develop our comprehension of the universe. The telescope's capacity to dissect the climates of exoplanets with phenomenal detail could prompt momentous revelations by identifying biosignatures, signs of life such as unambiguous gases or substance designs. Researchers desire to identify planets where life might exist or have existed in the past. Future missions and headways in technology will probably expand upon the establishment laid by the JWST. New telescopes and space missions are expected to additionally refine our look for livable worlds and possibly life-maintaining conditions. For instance, the next-generation space observatories might have significantly further developed instruments capable of identifying fainter signals and examining exoplanets at more prominent distances. These advances will enhance our capacity to search for life across a broader range of conditions and environments. The investigation of exoplanets in the habitable zones of stars, particularly around red dwarfs, remains a priority. These stars offer an interesting opportunity to concentrate on planets that could have conditions similar to Earth's, despite being cooler and less luminous than our Sun. The TRAPPIST-1 framework, with its captivating array of Earth-sized planets, continues to be a focal point for space experts studying potential livability and life-supporting conditions. In addition, missions to different pieces of our planetary group, like Mars or the icy moons of Jupiter and Saturn, will also play a critical role in the search for life. Disclosures made in our own solar system, for example, potential biosignatures on Mars or subsurface seas on moons like Europa and Enceladus, could provide significant hints about the presence of life beyond Earth and inform our search strategies for far-off exoplanets. The integration of data from the JWST with ground-based observations and other space missions will provide a more comprehensive image of the universe. Cooperative endeavors among global space organizations, research establishments, and the scientific community will be pivotal in interpreting discoveries and developing new research avenues. The cooperative energy between different